Welcome back to the sixth episode of Demystifying AI, everyone. Today, we're delving deep into a topic that's been on everyone's minds: how AI is fundamentally reshaping the world of software development, and indeed, our everyday interactions with technology. It's an extremely unique and very interesting time to enter the industry right now. It feels both exciting and perhaps a little bit daunting, wouldn't you agree?
Absolutely. It feels like the ground is shifting beneath our feet. We recently came across a fascinating talk by Andrej Karpathy, former director of AI at Tesla, and he really lays out this evolution of software in a way that just makes so much sense. He argues that software is changing again, quite fundamentally, in a way it hasn't for about 70 years, but now it's had two rapid shifts in just the last few years.
He breaks it down into three distinct eras, doesn't he?
He does. So software 1.0 is what most of us traditionally think of. The computer code you write directly for the computer, like C++ or Python. Then came software 2.0, which he identifies as neural networks, specifically their weights. Here, you're not writing the code directly, you're more kind of like tuning the data sets, and then you're running an optimizer to create the parameters of this neural network. An example of this would be the neural networks used for image recognition. Karpathy even noted that at Tesla, the autopilot C++ code, which was software 1.0, was quite literally being deleted as neural networks grew in capability and size, with functionalities migrating from 1.0 to 2.0.
And now, the truly revolutionary part: software 3.0.
Yes, and this is where large language models, or LLMs, come into play. Karpathy sees this as a completely new kind of computer. In software 3.0, your prompts are now the programs that program the LLM. And remarkably, these prompts are often written in plain English. It's a new programming paradigm entirely.
It's quite mind-blowing when you think about it. The idea that we're programming computers in our native language, it's something Karpathy himself tweeted about, and it's his currently pinned tweet. He draws some really interesting analogies for these LLMs, comparing them to utilities like electricity, or even semiconductor fabrication plants, or fabs.
That's right. He explains that LLM labs like OpenAI or Google's Gemini spend huge capital, CapEx, to train the LLMs, much like building an electricity grid. Then there are operational costs, OpEx, to serve that intelligence via APIs, which we pay for, just like metered access for electricity. He even pointed out that when state-of-the-art LLMs went down recently, it actually felt like an intelligence brownout in the world, highlighting our increasing reliance.
But the analogy he seems to find most compelling is that LLMs are very much like operating systems. They aren't just commodities. These are now increasingly complex software ecosystems. We're seeing a similar ecosystem shape up with a few closed-source providers like Windows or macOS, and an open-source alternative like the Llama ecosystem mirroring Linux. He says it feels like we're in the 1960s-ish era of computing again, where LLM compute is still very expensive and centralized in the cloud, and we're all just thin clients interacting with it over the network. He even noted that when he talks to an LLM directly, in text, it feels like talking to an operating system through the terminal.
And it's not just the technical similarities. Karpathy delves into the psychology of LLMs, describing them as stochastic simulations of people. Because they're trained on vast amounts of human text from the internet, they have an emergent human-like psychology.
Which means they come with their own superpowers and deficits, right?
Precisely. On the one hand, LLMs possess encyclopedic knowledge and memory, far exceeding any single human's capacity, having read so many things. Karpathy likens this to the savant character in the movie Rain Man, who could remember entire phone books. But they also have significant cognitive deficits. They hallucinate quite a bit and make up stuff. They exhibit jagged intelligence, being superhuman in some problem-solving domains, but making basic mistakes no human would. They also suffer from anterograde amnesia, meaning they don't natively learn and consolidate knowledge over time like humans do. Their context windows gets wiped out every single morning. And finally, they can be quite gullible, susceptible to prompt injection risks and data leaks.
So, how do we work with these powerful yet fallible systems? This leads us to the concept of partial autonomy apps.
This is where the magic happens. Instead of just interacting directly with the LLM like an operating system terminal, Karpathy suggests we need dedicated applications, much like Cursor for coding or Perplexity for research. These LLM apps have several key properties. They manage context for the LLMs. They orchestrate multiple calls to different LLMs. Crucially, they have application-specific GUIs. This is vital because reading and interpreting text from an LLM can be effortful. A visual representation like a red-green diff in code is much faster for humans to audit. GUIs utilize our computer vision GPU in all of our head, making verification faster. And finally, they feature an autonomy slider. This allows the user to tune the amount of autonomy given to the AI, from simple auto-completion to full agentic control over an entire repository. Karpathy, drawing on his Tesla autopilot experience, emphasizes that this is about building partial autonomy products rather than fully autonomous robots, especially with fallible LLMs.
This idea of keeping the AI on a leash comes up repeatedly, doesn't it?
Yes, it's a critical point. While LLMs can generate massive amounts of work instantly, humans are still the bottleneck in verification, ensuring quality, correctness, and security. So the goal is to make that generation verification loop as fast as possible. This means keeping the AI from being overreactive and generating overly large outputs like 10,000-line code diffs, which are hard to audit. It also means being more concrete in our prompts, reducing vagueness to increase the probability of successful verification and avoid endless loops of reprompting.
It sounds like a new skill set for developers and even everyday users. And speaking of new skills, Karpathy highlights something truly unprecedented: the idea that everyone is now a programmer because everyone speaks natural language like English.
This is the concept of vibe coding, a meme that emerged from one of Karpathy's own tweets. He shared a video of kids vibe coding, seeing it as a gateway drug to software development. He even tried it himself, building a basic iOS app without knowing Swift and a menu image generator app called MenuGen.
But he found that while coding with an LLM was easy, making the app real, handling authentication, payments, deployment was still incredibly difficult and time-consuming, requiring manual browser clicks and extensive DevOps work. This highlights a new challenge: building for agents.
Exactly. We need to adapt our digital infrastructure for this new consumer of information, the AI agent. This means creating LLM-friendly documentation in formats like Markdown, which LLMs can easily understand, rather than HTML or instructions full of CLIMC. Companies like Vercel and Stripe are already moving their documentation to be machine-readable, even replacing click with equivalent curl commands that an LLM agent could execute.
So with all this talk of AI doing the work, what's left for us, humans? This brings us to the insights from the article, The Human-AI Partnership in the Software 3.0 Era. It suggests that rather than fearing job displacement, we should embrace this partial autonomy approach, playing to our strengths.
The article really reinforces the crucial human role. It highlights 3 irreplaceable aspects. 1, deep domain expertise matters more than ever. LLMs can generate and analyze, but only a human with real-world context can guide them to the right answers. We become the architects of the solution. 2, internal system knowledge is irreplaceable. Our understanding of specific workflows, data pipelines, and organizational quirks is essential for navigating LLMs safely and efficiently. And 3, prompt crafting is a learned art. While anyone can type a basic request, turning that into a powerful, effective program for an LLM requires precision, iteration, and insight, much like traditional coding.
It's about augmentation, not replacement. Karpathy uses the Iron Man suit analogy for this, saying we should build Iron Man suits that augment human capabilities rather than fully autonomous Iron Man robots. The goal is to make the human's generation verification loop incredibly fast while gradually sliding towards more autonomy over time.
So in summary, it's an incredibly unique and interesting time to be entering or working in the software industry. We have these powerful yet fallible people spirits in the form of LLMs that are like early operating systems. Our job is to learn to program them effectively, which means building sophisticated partial autonomy apps with custom GUIs and embracing the autonomy slider. It also means adapting our digital world to be more accessible to these new AI agents.
It's a decade of agents, not just a year. And as the autonomy slider moves from left to right over the next decade, it's going to be fascinating to see what we build together, humans and AI, in this new era of software.